Hello, welcome to this video on connecting f, f prime, and f double prime graphs. Today we are going to go ahead and look at a given graph of f, f prime, and we're going to connect various features and information across these graphs. Additionally, the first and second derivatives will provide us information and ultimately justifications about our features of a function. So I want you to go ahead and look at these three graphs here. Our first graph, this is going to be f of x. The second graph is going to be f prime of x. And the third graph is f double prime of x. Now, when you're looking at a function, its maximum and minimum, the first things that you should see here at a and at b is that our slope is 0. Now you can see that and notice that here on this graph of f prime, where our slope at a and b are 0. Furthermore, if I'm looking at a function of f of x, on the interval less than a, notice my function is decreasing. My function values are decreasing, and therefore my derivative values are negative. So therefore, my function values, you can see here on f of x, are below the x-axis because it's negative. However, between a and b, now my function is increasing. This function is increasing, and my slope values are positive, meaning that f prime of x is positive, and therefore on the f prime of x graph, it is above the x-axis. Now, for the domain after b, again, our function is decreasing here. And we can see that, again, our values are below the x-axis. Okay, so let's go ahead and look at what this tells us about our function. If f of x is increasing, then f prime of x, this is going to be greater than 0. And if f of x is decreasing, well then f prime of x is less than 0. If f of x has a relative maximum, well that means that f prime is equal to 0, and it's going to change from positive to negative. From positive to negative. Now if f of x has a relative minimum, well, again, f prime is equal to 0, and this time we are going to change from negative to positive on our f prime. Okay, so looking at this graph, you can see here that f prime is equal to 0, so these are extrema, and since we're changing from decreasing to increasing, that is a relative minimum here. And when we change here from positive to negative, that's our function increasing and then decreasing. This is a relative maximum. Notice I cannot interpret or I cannot infer anything from for f double prime of x. Okay, so we're going to go ahead and get to that here in a moment. Alright, so now we're going to go ahead and we are going to connect all three of these graphs. Again, this graph here is f of x, this graph here is f prime of x, and this graph here is f double prime of x. So I'm going to go ahead and play the same game for f prime to f double prime. So I want you to notice here for f prime of x that we have a maximum here at c. So the slope of f prime here is 0, and notice that that is 0 for f double prime of x here. Now for f prime of x, f prime is increasing. The function values are increasing left of c. So all of these function values are increasing, which shows in our f double prime graph that our function is above the x-axis. Now our function starts to decrease after, and Therefore, f double prime is going to be negative. And notice that that is below. Okay, what are the implications on our function f? Well, if f double prime of x is greater than 0, notice on this interval up until c, our function, our actual function, is concave up. So notice up until c, it is concave up. And then where our f prime is decreasing, those function values for f double prime are negative, and therefore our function is concave down. Okay. Additionally, I would like to tie in together where f double prime crosses the x-axis, where we change from positive to negative. This is what's known as an inflection point. So that inflection point is here at C, and notice that that's the maximum value on our f prime graph. That's the steepest positive value that this slope has here for f prime. Okay, so let's go ahead and summarize in our table. If f of x is concave up, well, that meant that f prime is increasing. And f double prime was greater than 0. If f of x is concave down, well then f prime is decreasing, and f double prime is less than 0. And if f of x has a point of inflection, well, then f prime has a max or a min, and f double prime is equal to 0 and changes signs. Okay, so that's kind of connecting these three graphs together and looking at their features. In AP Calculus, you're going to have to go ahead and look at a derivative graph or a second derivative and then be able to determine what a possible graph could be, or answer questions about a function. So let's go ahead and look at some of these examples. So example 5, here is g prime and h prime. They say a graph of g prime is above. Determine the intervals where g of x is increasing and decreasing, as well as any relative extrema. Also, determine when g of x is concave up, down, and determine any x coordinates where g of x has a point of inflection. Okay, so I'm going to go ahead and I am going to do increasing and decreasing first. So we can say g is increasing on -2 to 0, union 3 to infinity, because g prime is greater than or equal to 0. Notice that's where my g prime is positive. G prime is positive, so therefore it's increasing. G is decreasing on -infinity to -2, union 0 to 3, because g prime of x is less than or equal to 0. Okay, so where we changed, however, that is going to be relative extrema. So we can say g has relative extrema at x equals -2, 0, and 3, because g prime changes signs. There you have it. So that's what the first derivative tells us. If it's above, we're increasing, the function's increasing. If it's below, the function's decreasing, and where you change is extrema. How about concavity? Well, g is concave up whenever g double prime is positive. So that's the derivative of g prime of x. So our graph is increasing up until -1, and then from 2 to infinity. So I can go ahead and say G is concave up on -infinity to -1, union 2 to infinity, because G double prime is greater than 0. Additionally, G is concave down on -1 to 2, because G double prime is less than 0. Okay, so you can see that it is less than 0. And then, do we have any points of inflection? We can say G has points of inflection at x equals, where did we change? -1 and 2. -1 and 2. Because G double prime changes signs. All right. Okay. So that is interpreting increasing, decreasing, and relative extrema. Again, we look at the sign values of the first derivative, and then concavity and inflection points come from the second derivative. I want you guys to go ahead and pause the video. I want you to try example 6 and answer the same questions about H with H prime given here. All right, hopefully you tried those examples. Here are the solutions for example 6. H is increasing on -1 to 1 and 4 to 6.5 closed intervals because H prime is greater than or equal to 0. You can see on the graph that our function is above the x-axis. Again, this is H prime, and that means that our function is increasing. It's decreasing whenever the function is below, whenever H prime is less than or equal to 0. So H is decreasing on 1 to 4, union 6.5 to 7 inclusive, because H prime is less than or equal to 0. Now, whenever we change signs, whenever we change from increasing to decreasing or decreasing to increasing, that's going to be a relative extrema. So we can say H has extrema at x equals 1, x equals 4, and x equals 6.5, because H prime changes signs. They change from positive to negative or vice versa. Looking at concavity, here are the solutions for concavity. H is concave up on 2 to 6 because H double prime is greater than 0. Our function is increasing. So let me go ahead and erase these colors. So now our function is concave up when it is increasing. So there's our function concave up, and it is concave down when we are decreasing. So from -1 to 2, union 6 to 7, because H double prime is less than 0. Whenever we change from concave up to concave down, that's an inflection point. So H has inflection points at x equals -1 to 6, because H double prime changes signs. All right, so those are some function analysis. Now let's go ahead, let's work from information given in a graph to identify an original function. So here are some multiple choice questions that you may see on the AP exam, and they say, given the graph of f prime, the derivative of the function f is shown to the right. Which of the following could be the graph of f? Okay, so here I have f prime, and they want us to find what f is. Well, I think it's important to take f prime and make a sign chart and just go ahead and interpret it. So where is f prime equal to 0? Well, it happens over here, and it happens over here. So on this side, f prime is positive. In the middle, it is negative, and it is positive. What does f prime tell you about a graph? Well, it tells you if a function is increasing. So our function's increasing here and here. And if it's negative, it can tell you if a function is decreasing, as well as if you have any extrema here. So what we can expect from our functions that we are increasing and then decreasing and then increasing. So looking at option A is a strictly increasing function. That's going to go out the window. Option B, we are decreasing, then we're increasing, and then we're decreasing. We like that pattern, but we want it flipped. Option C, increasing, decreasing, increasing. Okay, C's an option. And then D, decreasing. No, that's not what we want. Increasing, decreasing, increasing. It is not D. C is our answer. C is our answer. Example 7. A similar setup. We have the graph of f double prime, the second derivative of the function f, is shown to the right on the interval 0 to 8. Which of the following could be the graph of f? Okay, so here I have f double prime. Again, I'm going to make a sign chart just to help me interpret it the same way, starting here at 0. And at 2, we switch from positive to negative. And it looks like after 2, 1, 3, 4, 5, about 5.5, we switch back to above. Okay, I'm looking for a graph that is concave up, then concave down, and then concave up. So option 1, concave up, and then it turns to concave down. Well, that doesn't ever turn back to concave up, so not A. B, concave down, then concave up, and then concave down. Again, that's kind of the same pattern that we like, but it needs to be flipped. C, we're concave up, and then just after 2, we're concave down, and then we're concave up again. Okay, C is a possible option. D, concave up, concave down, okay, but it kind of happens too early to where we go back to concave up. Notice that this is happening about 1, we want it to happen at about 2. Then we're concave up and then down and then up again. That's way too many changes according to our derivative graph. So it's not D. C is the answer. No, the answer is not always C. That's just a coincidence. Okay, I have an example, actually a couple of examples. If you have the notes, you can go ahead and try these. If not, I'll pause, I'll show you the answer to this one, and then I'll show you the next one. So go ahead, pause the video, try this example. All right, here is a graph of f prime, and f prime is negative here, then it's positive, and then it's negative. Well, that's going to tell me that my graph is decreasing and then increasing and then decreasing. A is not the answer because that's a strictly decreasing graph. For B, we're increasing, then decreasing, and then increasing. It's not B. For C, we are decreasing, then increasing, and then decreasing. C is an option. And then for D, decreasing, increasing, kind of flattens out, and then it keeps increasing. It's not D. The answer here is C. Hopefully you got C. Okay, next practice problem. Please go ahead, pause the video, and try this example. Our graph of f double prime tells us that our function is concave down from 0 to 1 because it's below the axis. It's above the x-axis from 1 to 4, therefore our function will be concave up on this interval, and then concave down on 4 to 6. So let's go ahead and look at our options. Option A, we are concave down, it looks like from 0 to 2.5, and then we're concave up. That does not match our sign chart, so A goes out the window. B, we are concave up, it looks like, to start with, up until about 3, and then concave down. Again, I'm looking for 3 different concavities. On C, 0 to 1, if you look closely here, it looks like it is roughly concave down, then we're concave up, and then concave down again from 4 to 6. Okay, so C could be an option. And then on D, we're concave down from 0 to 1, and then we're concave up until about 3, and then we're concave down here on 3 to 4. So notice that doesn't match, and then it goes concave up again. D is not the answer. The answer is C. All of those answers were C. Is this the answer? C. All right, that's going to do it for this video. In this video, we connected graphs of f, f prime, and f double prime to determine features and justify certain information. I'll catch you in the next video. Give me a thumbs up.